In this last video, we're going to take a look at how to use a tree diagram to calculate probability. So we have a bag of marbles with 3 red and 2 blue. We're first going to draw a diagram of all of the different ways that we could pull 3 marbles out of the bag, putting the probability next to each line because the probability is different based on if it's a red or a blue marble. And then we'll calculate the probability of drawing 2 blue and 1 red in any order. So we started with the bag of marbles, and that's notated here. We had the 2 blue and 3 red. And then this is the line that what happens if we draw a blue marble. So the blue marble comes out and there's a 2/5 chance that our first pull is a blue marble. And then we've got the line below it, and that's the probability of drawing out a red marble. And there's a 3/5 chance that our first pull is a red. And then you can see the pictures of what would be left based on what we drew. So that's our first pull. Our second pull, if we draw another blue, that would be a 1 out of 4 chance. So you can tell that this is dependent probability. We're not replacing it. There's only 4 marbles left in the bag, only one of which is blue. And then the probability that our second pull is red would be 3 out of 4. Okay, so if we pulled a blue marble, there would be 3 red marbles left. And if we pulled a red marble, there would be 2 red marbles left and 1 blue one. So the probability that we draw a third blue is 0. There aren't any blue marbles left. We pulled the 2 on our first 2 pulls. And the probability that we get a red on the third pull in this case would be 1, or 3 out of 3. All the marbles left are red. There's a 100% chance we grab a red one on that third pull. For the next line, we've got a 1 out of 3 chance of pulling a blue and a 2 out of 3 chance of pulling a red. This line here was our second pull if we got blue on the first pull. We haven't looked at what would happen if we got red on the first pull. And then this would be the third pull if we got blue on the first pull and then red or blue on the second. So now we're going to take a look at the second option if we drew red the first time around. And I made my tree diagram a little too big because I'm running out of room for my blue marbles. So I'm going to move my first pull down if I got the red one. I'm going to say that here is my red line, and that was a 3 out of 5% chance of happening. And there were 2 red and 2 blue marbles left. So from there, again, that was my first pull if the red marble was on my first pull. So the chance that I get a blue marble on that second pull then would be 2 out of 4, and there would be 1 blue marble left with 2 red. So if I pulled a red, I again have a 2 out of 4 chance, but this time I would have 1 red marble left and 2 blue. So that would be my second pull if the first pull was red. And then my third pull, if my second pull was blue, my third pull I'd have a 1 out of 3 chance of pulling a blue marble, a 2 out of 3 chance of pulling that red one. If I pulled red and then red, I would have a 2 out of 3 chance of pulling a blue marble, and only a 1 out of 3 chance that that third pull would be red. All right, now we can calculate our probability. The question was, what's the probability that we pull 2 blue and 1 red in any order? So now we need to follow our tree diagram and determine the probability. All right, so we have blue, blue, red here. So we can multiply those probabilities together. So that was 2/5 times 1/4 times 1. Or 3 out of 3. I'm going to change that to 3 out of 3 for the common denominator for the other probabilities. So this was the probability that I pulled blue, then red. And those were and, which is why we're multiplying blue, and then red. And I'm actually combining this with the or probability because then we're looking at or what's the probability that we pulled blue, then red, then blue. That's still 2 blues and 1 red. It's just in a different order. So 2/5, 3/4, 1/3. And because this is or now, we're adding the probabilities together. And this was blue, red, blue, and it was 2/5, 3/4, 1/3. Notice again, dependent probabilities, they changed based on what happened. And we had one more option. So if we pulled red first and then 2 blues. So again, this is or red, blue, blue. So these are all of the ways that we could get 2 blue and 1 red out of 3 pulls in any order. So this was 3/5 times 2/4 times 1/3. Now notice that all of our numerators are the same. 2 times 1 times 3, 2 times 3 times 1, 3 times 2 times 1. So I'm going to go ahead and simplify because of course all of my denominators are the same as well. 5, 4, 3, that dependent probability. First there were 5 marbles, then there were 4, then there were 3, regardless of what color we pulled out each time. So I'm going to start simplifying each of these. I'll still end up with a common denominator because of the same numerator, same denominator situation. So 3/3 cancels, 2 goes into 4 twice, so we have a 1/10 probability. And that's going to be the same for all of them. The 3's cancel, 2 goes into 4, so we've got 1/10. And the last one, 3's cancel, 2 goes into 4 twice, so we still have a 1/10 probability. So our total probability of 2 blues and 1 red in any order is 3/10. And here are your U-Try questions. Enjoy!